With support from the Office of Naval Research, Virginia Tech has developed a series of open-source learning simulations for radio frequency and wireless communications concepts, as well as for radio frequency spectrum sharing and spectrum agility. We'll be right back with a preview of one of the simulations.
Please see the video description for a full list of disclaimers, including the ones here, plus a timeline and helpful resources and links. Please support the channel by using our affiliate links.
This simulation shows the difference between observing part of the radio spectrum using logarithmic units, in this case decibels, as opposed to linear units. I'll point out a few features of this simulation that are common to the other simulations in the series called HLSI, which stands for Hands-on Learning for Radio Frequency Spectrum Innovation. First, these simulations are somewhat abstracted. They're based on a combination of theoretical and empirical information, but the noise floor in this case is represented as a flat line. Also, the signals are somewhat simplified, and you won't see variation across the signal bandwidth. In this case, by default, it uses a linear scale, and you can see one strong signal here and one weaker signal. Again, this is using a linear scale, so the signals would be measured in units of watts per hertz, for example. If you think of this as a power spectral density plot, in this case, the values on the vertical axis are just normalized values, so they don't necessarily correspond to absolute values. But again, the purpose of these simulations is to introduce students or other learners to concepts in wireless communication and to allow them to interact with the simulation in a way that they can explore those concepts. This is one of the simpler exercises in the series. The only control on the screen is one that lets you switch between units such as watts per hertz and logarithmic units such as dBm per hertz. But again, the vertical axis in this case is relative. Right now you're looking at the simulation at 100% on a full HD or 1080p screen, and we can change that magnification or the zoom level. In most browsers you can use Control plus, Control minus, and you'll see a change in the size of the display. So I'm just going to use Control plus to zoom in. We can use Control minus to zoom out. And in some of the simulations, that's more important because some of them have many more controls or more graphs, and you may want to ensure that multiple graphs and controls appear on the screen at once, or that they're large enough to read. As you see, both the source code and the web pages for the simulations are available through GitHub. So I'll leave it to you to try out the simulation and see the effect of changing the scales for power spectral density. I hope to see you again as we demonstrate another simulation in the series.
Thanks for your time. Please hit like and subscribe and support the channel by using our affiliate link if you plan to buy a featured item. We also provide consulting services and referrals.